The next important question on Poisson distribution would be how to fit a Poisson distribution to the given data. This is again an examiner's question of interest. Okay. You are being given a data with a set of values X and there are frequencies. These would be called observed frequencies, F1, F2, and so on. Sum of all these frequencies, I'll be calling it to be capital N. Okay, I'll be notating it to be capital N because actually that N gives me the total number of things that under consideration. Okay, now how do I fit? Fitting is very easy actually. It's all about which distribution you are fitting. Especially when it's Poisson, is even more easy. Why? Because I'll tell it a little later. But then how do I do the fitting is, I just write all the X values here and then P of X values I'll be calculating. You know what's the P of X or P of R formula for Poisson distribution. It is e power X e power minus lambda power x by x factorial. It's that formula. So using that formula for whatever values of x1, x2, all those are there, I'll be putting and calculating the probabilities P1, P2, and so on, Pn. And then I've calculated the sum of all frequencies and notated it by capital N. I'll be multiplying all these probabilities that I've obtained using Poisson distribution by this capital N. These would be called the expected frequencies, guys. The ones that are being given in the table would be the observed frequencies and the ones that you have calculated using a certain distribution, whether it is Poisson, normal or binomial or whatever, using that distribution, whatever you have calculated, those will be expected frequencies. Okay, very simple, actually very simple question. Sounds to be as if it is very difficult, but fitting a Poisson distribution to the given data is the most easiest or a trivial question in my opinion. Of course, why trivial if you ask me? Again, I have one more thing to say. Once I know P1, I can generate all the other probabilities for Poisson. Why? Because I've already discussed in the previous video just before the example that I have a recurrence relation. I generated a recurrence relation between PR plus 1 and PR. If you remember or if you watch that video, you will know I've generated a recurrence relation between this one, PR plus 1 and PR. Okay. So once I know P1, I can generate all the other ones instead of going with that hectic E per lambda, lambda per x, x factorial. Instead of going with that hectic thing, I can just generate using the recurrence relation. What is that recurrence relation? P of R plus 1. Very simple to remember. Whatever extras are there in R plus 1, I have written them out. Remaining things come under P of R only. Lambda was there and R plus 1 is there as extra P of R. Once I know, I just calculate P of 1. Then P2 I'll be calculating using this recurrence relation. That's the reason fitting a Poisson distribution to the given data is the most easiest or a trivial question, provided you know the procedure. Okay, and it's an easy question to attempt, a scoring question to attempt. Let's see a problem and you will understand what exactly I'm talking about. Example is fit a Poisson distribution to the following data. I'm being given something like number of mistakes per page. Again, this is a Gupta and Kapoor standard problem, guys. It's an favorite problem for the examiner as well. Okay, number of mistakes per page are given to be 0, 1, 2, 3, and 4. And the number of pages are given. So, this I'll be calling to be Fi. This I'll be calling to be Xi. Okay, 0 mistakes, 109 pages, 0 mistakes. One mistake in 65 pages, 2 mistakes in 22, 3 mistakes in 3, and 4 mistakes in 1. So first what I'll do is I'll find out capital N, which is nothing but the sum of all the frequencies. 109 plus 65 would be 174. 174 plus 174 plus 22 would be 196. 196 plus 3 would be 199 and plus 1 would be 200. So my capital N is 200. Once I know capital N, I can use any way to find my fit the, okay, these are all, by the way, observed frequencies. Whatever are given in the table or in the problem, they'll be observed frequencies, guys, observed frequencies. And what I'll be doing, I'll be doing PD, fitting fitting PD to the given one. How will I do it? I'll write all these X values here. 0, 1, 2, 3, and 4. 3 and 4 I'll be writing here. I won't write the frequencies anymore. Already I made the sum of the frequencies. So I don't need that. Next thing what I'll do is I'll be going with fitting Poisson distribution directly. What is that? I'll be calculating P of X directly. Okay, P of X. Okay. For P of X, I'll be needing lambda, na? Lambda. Lambda is nothing but averaging parameter. Averaging parameter or average. Okay, so how do I calculate average when I have xi and fi? How do I calculate average or mean or average, whatever, lambda? Okay, anything is fine. This is how I'll calculate summation xi fi by summation fi, right? So I'll be multiplying 0 into 109 plus 1 into 65 plus 2 into 22 plus 3 into 3 plus 4 into 1 by 200 is what I've got to be summation fi, right? I'll be calculating this some lambda value, the average value I'll be getting. I have the answer with me. Lambda is 0.61. Once I have lambda, I'll proceed with the table. What's the table? I'll be calculating what? E power minus lambda. E power minus 0.61 into, e power minus lambda, lambda power x by x factorial, right? Similarly here also e power minus lambda, lambda power 1 by 1 factorial, lambda is 0.61. Okay, if you have to do like this, you definitely should have a calculator. You can't do manually. Okay, lambda is again 0.61 only, so I'm not writing. Lambda power 2 by 2 factorial. Similarly, e power minus 0.61, lambda power 3 by 3 factorial, e power minus 0.61, lambda power 4 by 4 factorial. All these values I will calculate. I again have these answers. I can just write them for you so that the question is not incomplete. 0.543 is what I have here. 0.61 is what I have here. Here I'll be having 0.61 by 2 is what I have here. May not be. May not be that one. Okay. So, okay, just a second. May not be. These values may not be correct. This is correct anyways. This may not be correct. These two may not be correct. Okay. This is correct anyways. I'll just skip off. Instead, I will write the proper fitting part or the expected frequencies part. Expected frequencies, how do I calculate? N into P of 0. Okay, once I know P of 0, remaining things can be generated. Anyways, I have written N into P of 0, right? N into P of 1, I'll be calculating. N into P of 2, I'll be calculating. N into P of 3, I'll be calculating. N into P of 4, I'll be calculating. That is it about fitting. Very simple, very easy, provided you know. Okay, of course, sometimes they'll ask what's the difference between the observed and the expected frequencies. You should be able to cross check. Also, see to it that your answer is correct or not. You can check using observed frequencies, guys. Whether your calculations are deviating or are you on the right path, you can check using the observed frequencies that are being given in the table, because not much variation will be there between observed and expected frequencies. I have the answers. By the way, I can write them for you here, the different colors so that it's visible. These answers I have with me. It is 108.64 here. Of course, it's a frequency and it should be a number, so I can round it off. 66.27, I can round it off to 108 or 109. Anything is fine. Here I can round it off to 66. Okay, 20.21, I can round it off to 20. 4.11, I can round it off to 4. And 0.63, I can round it off to 1. Okay, this is how these are the expected frequencies. Observed frequencies are also there. You can observe there's not much deviation from the observed and the expected frequencies. Okay, this is how I'll fit a Poisson distribution to the given data. Okay, binomial also similar ways. I'll be using the different formula, binomial formula, right? Anyways, binomial is out of the scope of our syllabus.